7, hopefully.
Yeah. Okay.
In Good afternoon, good morning, good depending on whatever place you are right now. As you can see, some of the people are joining from outside India. So I, Anupam Bhattakur, on behalf of IEEE Computer Society, Student 1 chapter, welcome you all to this technical talk, which will be based on feature selection in machine learning, to be delivered by Dr. Nazrul Hoque. So I thank Nazrul sir for accepting our invitation to give a talk in this society. Going forward, as we just give a short intro of the speaker so that we can more focus on the talk that we'll have now. Dr. Nazrul Hoque has completed his Ph.D. from Tezpur University in 2017, currently working as a assistant professor in Department of Computer Science Engineering in Manipur University. He has published more than 20 papers in reputed international and national conferences. His research area includes intersection of network security, machine learning, IoT, and he mostly works on the area of machine learning itself, which the talk is all about today. We just handing over the talk. I just give some instruction that need to be followed by the audience. So to keep aligned, we kindly request everyone to keep your mic and video off during the period of the talk. If you have the queries, you can drop it in the chat box itself. We're also circulating some forms that you can fill up the particular form and put the query up. We forward the query to our lecture at the due point of time. And also make sure that you fill the attendance sheet that will be circulated after a period of time in the chat itself in all the social media platform. And if in case you are not able to sign in the Google, if any kind of difficulties are facing, you can directly go in our YouTube or Facebook medium to enjoy this particular talk. With this, I will hand over the platform to Dr. Nazrul Hoque, sir.
Thank you so much, Anupam. My dear
Yes.
participant, good evening to all of you. I am Dr. Nazrul Hoque from the Department of Computer Science, Manipur University. First of all, I would like to thank the organizing committee members of this uh, webinar, especially the IEEE Computer Society, Kharagpur sectors, for initiating such a nice program. It's not a one day program. I know this is a continuous program that giving too much effort to make this program as successful and useful for the participants. Thank you so much. And especially, I'm very much thankful to all of you for giving me the opportunity to deliver a talk here in this important and excellent place. Thank you all. Okay, so today I will be delivering a talk on feature selection in machine learning. Okay, let me share the screen. Is it okay?
Sir.
Okay. So my topic of discussion is feature selection in machine learning. So already we know that machine learning is nowadays used everywhere in our day-to-day activities. Without our knowledge or without our knowledge, many times we are using machine learning things in our day-to-day activities. Okay, and especially this machine learning or deep learning, these things are widely used in many areas of science and technology, especially for data analysis. And we know that nowadays the data analysis is a common thing. Any areas like healthcare, network, even smart cities or IoT, even chemical engineering, physics, they are using this machine. Okay, and we try to build some machine learning model for solving some problems ourselves. And when we design some machine learning problem, the feature selection plays an important role because feature selection is a kind of feature engineering. And why that feature selection is important? Because we take some data. Suppose if I consider the network application, especially maybe IoT network or any type of network, basically we will take some raw data. But that raw data, you cannot directly apply for predictive fit to the machine learning model. Before giving the data to your machine learning model, you have to pre-process. You have to convert the data to that level so that machine learning algorithm can understand. Okay, so to that line, okay, I am just trying to give you a overview about the feature selection or what is dimensional prediction. But feature selection is a very generic technique, and already so many works have been done in the last 3-4 decades. This feature selection is applied in any areas of data. So many works have been done. It's not a new topic. It's a very old topic. Since I am very, that means I have done some works on feature selection, and this is very interesting for me. Feature selection, feature extraction, dimensional reduction is very interesting work. So I have picked up this topic, and I will be sharing some knowledge, my little knowledge among you. So directly I'm going to the introduction part. This is the outline. Okay, so in my talk, I'll be covering about feature selection, what is the importance of feature selection, how it helps the machine learning model. And if time permits, I will show you one very important tool called Weka. This is an open source tool. And using the Weka toolbox, we can select some features or we can perform some machine learning operation. So now, what is machine learning? So basically, these two terms, machine and learning. So already we know what is a machine. Okay, machine, you can simply take it as a computer. And how can computer automatically without involving an human? The computer has the ability to learn something. So basically, machine, although it looks like a computer, yeah, that's good, but it's something like a mathematical model or abstract. If you say a Turing machine, from the Turing machine itself, you are getting the model. That's why it's something like a Turing machine, like mathematical model or abstract. And that model will take huge amount of data. And from the data itself, it will extract some knowledge without involving any human. And if your computer, if your abstract model can gain sufficient knowledge from the given data, then you can say that your machine has learned. That's why in 1957, probably, Samuel Alter, he found the word machine learning. If your machine can learn something from the data without being explicitly put. That means computer has the ability to learn something. That is called machine. And in neural definition, Mitchell says that suppose you are going to solve a problem. You have a task, suppose C, and you are going to solve that task by some experience E. And when you are solving a task with some experience E, and you are measuring the performance of P. So three terminology I'm using: experience E, task E, and performance P. Now, after training, if your model performs better, if the performance is increased with sufficient experience, that is, you can say sufficient amount of data that you are using to solve a particular problem, and you found that, after training, you found that your performance on doing is increased, then you can say that machine has learned. Okay, so these things will elaborate more, but the technical definition is this. These two we can take with the theoretical definition. And in many applications, like disease diagnosis, now this machine learning, deep learning, these things are learning things were widely used in healthcare. Now the people are using deep learning, machine learning for disease analysis, disease prediction. They can use huge amount of data to predict whether the disease is cancer or not. The things. And network traffic analysis, already I have mentioned. You can classify whether network flow or the network packet is traffic or whether it is attack or not. Similarly, self-driving car also people are using huge machine learning. Take an example. I'm giving an example. Suppose why we are using machine learning. Let's take this example. Suppose an emergency room in a hospital measures 17 different variables. Suppose one person is coming to the hospital and immediately the concerned person of the hospital will take some parameters of the patient, variables, like blood pressure, blood sugar, creatinine level, or age, temperature. There were 17 different variables were taken from the patient. Now, hospital authorities should take a decision whether the newly coming the patient will be admitted to ICU or not. Due to the high cost of ICU or unavailability of the ICU, those patients who may survive less than a month, they will be given higher priority on a side. So decision. So the problem for this, in this example, the problem is to predict the high risk patient from the low risk. Very simple thing. We may think that it's a very simple. We have different variables, values. We can easily say, or doctor can easily say whether he should be admitted to ICU or not within 8 minutes. Where is the importance of machine learning here? Do you think that the machine learning is really important for application? Many of you think that why machine learning is important. We can, any doctor can verify the 17 or 10, 12 immediately he can decide. Serious. Immediately you step into the ICU. So where is the importance of machine learning? Although you are thinking that there is no importance of machine learning, if you apply machine learning, then it is more useful. So I am going to discuss how it becomes more useful. See, why we should use machine learning. In that particular example, a doctor can use some decision-making process by writing some if rule. If the blood sugar is 400 plus, if creatinine level is 3, age is 75. So by using some if else rules, the doctor can decide. It is manual process. Manually, the expert is writing some rules. And according to the rules, he can decide that, yeah, this person is very serious, so it should be, the person should be admitted to the hospital. That's fine. The manual, for doing the manual process, expert is required. One expert is required. And the expert should have sufficient knowledge to write the decision-making rules. Secondly, most importantly, the same expert cannot write the rules for different applications. If you apply, that is, if you send the application from healthcare to suppose finance or agriculture or some other things, then the same expert cannot write the decision-making rules. And in our daily life activities, the application may be very dynamic. This manual process is not feasible at all for daily manual processes. Many times the doctor can make some mistakes, especially in healthcare, that is medical data analysis. If there is minor mistakes, it can create major problems. Okay. So what we can do, we can apply machine learning. So if machine learning algorithms are used, then automatically it can take some decision making. It can take decision automatically without having an. And the algorithm is able to create an output for an input it has never seen before without any help of it. It can predict the future also. It can take the future decision also from the data itself, from the knowledge it has gained during the time of training. The only thing is that, the only important thing is that the process, that machine learning, that whole process requires a huge amount of meaningful data. From the data itself, it will gain all the knowledge, all the rules, all the logics, everything it will, machine will get from the data. So the data is playing the major role. And you have to use the meaningful. So what is the meaning of meaningful? You cannot use any arbitrary data. There should be some meaningful here. It is relevant. In that point, I'm going to discuss the feature selection or attribute selection or variable selection. Okay, so meaningful data you have to use. You cannot use any arbitrary data. Now, once your data is meaningful, and machine learning generally it has some training and testing. In the time of training, what you are doing, you are giving sufficient knowledge to your machine so that it can automatically identify the decision rules. It can give you logic of your problem. It is the difference between traditional learning and machine learning. In traditional learning, what you are doing, you give input that you give, that means you give the input data and you have it will give you the output. But in case of machine learning, you will give input and then another input is the output. And what it will give you, it will give you the logic. Okay. So feature selection, it means suppose you have a large, suppose you have a suppose you have a large feature set or you have a big feature pool. And from that feature pool, you are selecting some features. This is very simple. In a simple word, I'm saying you have n numbers of features. And from that n numbers of features, you are selecting suppose less than n number of features. Maybe 5, 6, 10 features you are selecting. But how can you decide that these 5 features will be the optimal or the basic? Okay, the feature selection simply says that the selection method will pick up some informative features. That's all. Informative features. But how we can decide, how we can choose, or how we can say that this feature is informative. And when you apply feature selection, any feature selection method always tries to remove redundant features, irrelevant features, and noisy features. These are not important at all for a machine learning model to analyze this. This type of feature, redundant, irrelevant, and noisy features will not help the machine learning model during data analysis. So, as a pre-processing step, feature selection is known as pre-processing step, as I have told. And during the pre-processing step itself, the feature selection will try to remove all the garbage, and it will keep only the informative and meaningful features. And here is another, that is pre-processing step called feature extraction, which is also known as dimensionality reduction, that tries to create new features by some combination or transformation of the existing. Okay. Suppose you are taking a raw network data. And from the raw network data, you can as many as features. maybe hundreds of features you are expecting in a frog flow. But do you think that all the hundreds of features of a flow is really important to analyze, to identify, to classify that flow, whether it will be attack flow or not? It's not required all the time. Okay. If we use features to classify one flow, whether it is attack or normal, what will be the drop? And there are so many drawbacks. And those drawbacks will be overcome if you perform some dimensionality reduction techniques and feature selection techniques. Right? So the feature selection is also known as optimization. Why it is an optimization problem? Because you have to pick up a subset of features from the large feature pool that should give better accuracy to the model. This subset of features, which you have selected as an optimal subset of features, and using that subset of features, machine learning algorithms should give better accuracy, better performance. Then in feature selection, basically there are two steps. The first step is search the space of possible features. Say, as I have mentioned, you have to search all the feature space to find out the best possible. Out of n features, you have to pick up the best features. But how can you pick? And to decide whether the feature is best or not, that will be good or not, you have to use some evaluation or objective function as an evaluator. You have to evaluate. Suppose in a classroom there are hundreds of students, and you want to rank the students as 1 to 100. You cannot put the rank arbitrarily. If you want to make a merit list, you can put them arbitrarily as 1 to 3. You have to conduct some exam, you have to evaluate. Same way, if you have hundreds of features, if you want to give them some rank, and according to the rank, if you want to pick up as 10 features, then there will be some exam or evaluation. And that evaluation process is basically objective. With the help of some objective function, you are going to analyze each feature, whether that is important or not. And based on the nature of the objective function, you are going to give some names. Then, out of 100 features, suppose you want to pick up 10, 15, or 20. Accordingly, you can pick. The most critical task is to design the objective function. Okay, so people are using different types of techniques to design the objective function. So this is the basic process. So suppose you have training data. So in machine learning, we use some training data, and in the training data, you are using the complete piece of set. Okay? And then the training data will be used by the feature selection phase, feature subset selection. As I have mentioned, the feature subset selection process involves two steps. One is called searching, another is called objective function. First, searching will be performed, and after searching, whatever features the search operation gets, that features will be given to the objective function, and that objective function will measure the goodness, whether the feature is good or bad. And according to the goodness value, the search operation will take the decision whether that will be selected or not. And finally, this is a continuous process until you rank all the features, or until the search process fulfills the selection criteria. Suppose out of 100 features, if you want to take 9 features, till that the selection process will continue. And after that, the final subset of features will be given to pattern recognition algorithm. So this is a generic steps. Basically, any feature selection use. Thank you. So this is the basic for feature selection. Any feature selection method will use this type of technique. Now, why this feature selection is important? Earlier I told now the feature selection out of 100 features, if you take all 100 features instead of taking less than 100 features, what may be the drawbacks? First drawback is that if you take unnecessarily 100 features, all the features, out of 100 you are taking 100 features, but all features are not equally important to solve your task. Then what may be the drawbacks? First drawback is that learning algorithm will take too much time during. Computational cost will be first case. Next is that if you have high dimensional data or number of features is 4, there may be some irrelevant features. Then what may happen? Your model may face overfitting. So in overfitting problem, at the time of training, the model is perfectly fit to the data. But at the time of testing, your model will not be able to generalize the difference. That means, in other words, I can see the performance at the time of testing will be degrading as compared to the training. Right? And training time will be more if we use so many features, unnecessary. So to overcome all these problems, feature selection. So it enables the machines learning algorithm to train. If you use smaller number of features, then definitely training time will be less. It reduces the complexity of the model. And most importantly, another point I make, if your feature selection method selects the best subset of features, then definitely it will improve the performance of the model. This is most important. That's why excellent feature selection. If you can find out the optimal subset of features, then the feature set will definitely improve, or at least it will give similar accuracy like all the features. Then it reduces overfitting. So these are the main importance of feature selection. So what type of feature selection method we can use in machine learning? Generally, two generic types of feature selection is used. One is supervised feature selection, another is unsupervised. In addition to that, some people use semi-supervised feature selection. So in supervised feature selection, briefly, if you use some label information, label data, and with the help of the label data, if you are picking up the best set of features, that is also. In case of unsupervised, no label data will be used, and without using the label data, you are getting the features. Based on evaluation criteria, as I have mentioned, that evaluation criteria will play the major role. So based on the evaluation criteria, there are 4 different types of method. Filter method, wrapper method, embedded method, and hybrid. And anyone can design your own filter, wrapper, embedded, or hybrid. So what is filter? So filter means you are picking up one by one features. You have a large feature set, you are evaluating individual features, you are giving some rank based on the objective function, and you are picking up the base rank, suppose 5, 10, or whatever k numbers of features you are choosing, and accordingly you are selecting that k numbers. So how you are evaluating? Using objective function or evaluate. So one evaluation or objective function will be required. Okay, that is basically some information theoretical methods. So you can realistic measure or statistical measure also you can use to evaluate each feature or a set of features. But here, no learning algorithm will be used. Only objective function will decide whether that feature is important. No extra learning algorithm is required in this field. Then the objective function will give you ranking, first rank, second rank, third rank. Some example is chi-square or information gain methods or relief have so many. I'll show you in a way toolbox what are the filter feature selection methods you can use. And there are two types of filter feature selection. One is called based on data, univariate and multivariate. Univariate means individual features you are selecting. That means your objective function is working on each individual feature. And multivariate means the objective function may take 2 or 3 or combination of it. And accordingly, you are evaluating. So generally, the set of all features will be used first. Then, out of all features, select the best subset of features by using some evaluator or objective feature. After this step, whatever optimal subset of features you have selected, that will be given to some learning. But see, although here learning algorithm is shown, but this learning algorithm is not used in the time of selection of the best subset. This is why you are using the learning algorithm to evaluate the already selected subset of features are good or bad. For that reason, you can use the learning algorithm, and the learning algorithm will give it. But in case of REPAR, if you see here, the REPAR selection method, by default, that means implicitly it will use a learning algorithm. With the help of the learning algorithm, you have to select the features, a subset of features. So it's not separate. In filter, we didn't use any learning algorithm. Okay, but here this is inbuilt, you can see. The learning algorithm and the subset generation is a continuous process. With the help of the learning algorithm, it will decide whether the subset is good or bad. And after that, you can use any other, again, another learning algorithm to evaluate. The thing is that filter method will not computational that is better as compared to REPAR. Why? In REPAR method, every time you are using learning algorithm. In filter method, you are not using any learning algorithm every time. Each features will be evaluated by some evaluator. So it will not too much time. But in case of REPAR method, it will take too much time to find out the best. But performance-wise, REPAR method is better as compared to filter. Definitely, REPAR will be better because with the help of learning algorithm, you are selecting the features. The learning algorithm can tell what will be the performance of the selected features. That's why REPAR always gives better. In case of high dimensional data, you should not use REPAR because its computational cost will be very high. It's better to use filter. Now, people are thinking that why not we use some hybrid method by combining filter in it. So that way, many researchers, they are developing hybrid method by combining advantage and removing the disadvantage of REPAR. That way, they are developing hybrid. Okay, so hybrid is basically a combination of filter. But there is another feature selection method that is embedded. So embedded means, see, this is also important. Embedded means at the time of training the model. If at the time of training the model, if we can select features, it is very good. It is well and good. So that type of method is called embedded. So it selects features during the process of training. In the time of training itself, you can select the feature. In case of filter, that is not possible. First, you have to apply objective function, then select some features, and then you train the model. In case of REPAR, one algorithm learning model is used, the learning model will evaluate. That is the process. But in case of embedded, okay, at the time of training itself, you can select which features will be good or not. For example, the decision tree. When we make the decision tree with the help of some information theoretical measure like gain ratio, Gini index, root features. That is called base split features. And accordingly, you make the decision tree. So that features is selected because root features is selected because that will carry maximum information. And this embedded method is very specific to the F5 algorithm. Also you can use. Now, the complete taxonomy for feature selection or feature engineering is like this. I have taken this diagram from source given here. So basically, the feature engineering is divided into selection and feature selection. In feature selection, there is supervised. In under supervised, these four methods: filtered, hybrid, and embedded. And in unsupervised, again, you can use filtered, hybrid. In there may be some sequential, ion spread or iterative method, and univariate, as I have already told, univariate or multivariate methods are used for filtering. Okay. Then, what type of features you can select? Features may be noisy or irrelevant. Noisy and irrelevant means there are some features and attributes are very irrelevant, or they are not usual values. They are coming as a noise. They will not give you any information in data analysis. Okay, so noise or irrelevant is something very similar. Irrelevant is also something like that. That means it's for solving that particular task that some features are not giving any information. That is not related at all. Some features are redundant. Redundant means same. That is, you are selecting two features in the set, selection set. In the selected set, there are two features. So both the features are very different. So what is the use of keeping two features if they are carrying the similar? So that are always redundant features. So feature selection always try to remove such type of redundancy. Weakly relevant means they are giving little information, but that little information is not all. You can say in many cases maybe that is not important. And that's why that is termed as a weakly. They will not play any important role in classifying the object either as static or normal, or it will not play any role in classification. And there are some weakly relevant, but they are non-relevant. Weakly relevant, as I have already told, no significant information will be given, but they are non-redundant. We can keep because they are weakly relevant. They are non-redundant. One feature is non-redundant, so we can keep. That non-redundant feature is weakly relevant. So if it is weakly relevant, why should we select a feature? Because it will not give you required information. And strongly relevant. So basically, feature selection always tries to find a strongly relevant, because that such type of feature gives more and more information for your classification. So any feature selection not always best. Try to find such type of strongly relevant. And how can you decide which feature is strongly relevant, which feature is redundant, non-redundant, or weakly relevant? By using different objective function. So one such method, I just quickly giving how can you actually find out whether a feature is important. So mutual information is very widely used for filter. When you are designing filter this method, mutual information theoretic measures is very widely used. One such method is called mutual information based feature selection using non-dominated. Okay, here basically it uses feature class mutual information and feature mutual information. So feature class mutual information will give you the importance of a particular features in terms of that. Okay, this one's called feature. The class importance of that particular features with the class. And there are some features, that means feature mutual information. That means how much information you can get from two features in terms of visual information. Okay, so suppose sorry, suppose I'm considering four features: F1, F2, F10. So here F1 is visual information value is suppose 0.54, or F2 is 0.76, 0.17, and 0.33. These are feature class visual information value for individual features. Now you have to check the redundancy, because already suppose there are some selected features, and next which feature you are going to select. For that you have to say, before selecting a feature, you have to say, if I select that particular feature, will it be redundant to already existing? So to select that, what we can do, feature visual information. Okay, so if there are three already selected features, suppose F7, F8, F9, they are selected features. Now out of F1, F2, F3, F4 non-selected features, you want to find out one particular feature to be selected. Now, first you compute the feature class. These are the feature class information value for F1, F2, F3, F4. And next, feature will be computed for F1, F2, F3, F4, and for each selected feature, suppose F7, F8, F9. And this is the 0.17 is the average feature value. For F2, 0.09 is the average feature distribution value. For F3, 0.78 is the average feature distribution information value. Now, how can you decide which feature out of F1, F3, F4 will be the best one? So this is an optimization. So you are optimizing by using some different, anyone can use different optimization techniques. Suppose here, domination count and dominating count is used. So for this F1 feature in feature class MI, it dominates two features. That means F1 dominates F3 and F. That's why this is 2. F2 dominates all the 3. So that's why it is 3. F3 dominates none. So it is 0. F4 dominates 1. So this is 1. Similarly for these things. And what is the difference? The largest difference is 3 and corresponding to the feature F2. And that feature will be selected. In that way, people have designed different visual information approach for feature selection. Selecting the features, suppose you have selected k numbers of features and using different classifier, okay, using KNN or decision tree or random forest NPM, you can evaluate whether feature is good or bad in terms of like accuracy. Right? So you can use different validation methods. Selecting the features, you can use, you have to evaluate whether that features will be good or bad. So same thing like machine learning evaluation method you can use, like cross validation, decision recall measure. So these things you can use for evaluating this. Okay, so okay, and same thing for cross validation. That means this cross validation things is exactly same to the, that means machine learning cross validation. Only thing is that the subset will be used for evaluation by a machine learning. That's why whatever evaluation is used for machine learning, same thing you can use for feature selection also. So and lastly, I will just show you the Weka toolbox. So someone can use the Weka. So Weka is a freely available software for machine learning. You can use feature selection, clustering, classification, everything knowledge discovery you can use by using Weka. It's a very user-friendly tool. Only thing is that it will, that means you have to upload the data either in CSV format or .AR, attribute relation feature format. Okay, so that way you can, that means that type of data set either in CSV or in .arff, you can upload it here. So basically, for feature selection, you go to the explore, then you will get this interface. Here, first you have to upload a data. data set. So open files, you have to put the file containing your data. Suppose I am uploading any RFF data. So here you can see what are the attributes and what is the class level and their distribution, everything, statistics you can see. All right. Now you go to the select attribute. Here there is a select attribute, classify, cluster, association, select attribute, and visualization. So I want to perform feature selection, go to select attribute, then choose the method. So here different methods are here. If you go to choose option, then so many methods are here. All methods you can use for your comparison purpose. Suppose you have developed your own feature selection method. Next, you want to validate your method with some existing methods. Then instead of writing other programs, you can use these tools or you can use these methods, and then you can find out the result and you can. Okay, so CSV set evaluation. Suppose I choose this one, or you can say you can info gain. So once you select the info gain, then you have to use the ranker. So search method. As I have already told you, there will be some searching method, and that searching method is basically ranker. It will give you some rank, and you can use full training set, or you can put some validation, and then you can. So that means for some time it will give you the selected features. Okay, all the features according to the rank. Right, number 5 feature is the first rank, number 2 feature is the second rank. Then that way all the 10 features have been ranked according to some score. All right. Then these selected features, suppose out of 10 features you want to select only 5. So you just take 5 and reduce the data set, and that's performance of these selected features you can evaluate by using some classifier or machine learning. So I will stop here because it's already 7:50. So next question answering. So thank you all.
Thank you so much, sir. I know it's a really long topic. It cannot be covered in just a short period of time. I really thank your effort to summarize everything in just one particular go, and you have given a quite good description and overall flow of how we can use to actually particular software where it can be actually applied. So thank you, sir, for summarizing all the things. Okay. We have a couple of questions on this. So first of all, like, is there any generic method like which can be like which particular data feature selection method we can use beforehand to know like any particular data set is specified to some method, or it's like a trial and error we need to do?
Yeah, generic method. As far as my knowledge is concerned, there's any generic case of this because feature selection you can apply on numeric data, image data, or some video data, or some text data. So although the method may be same, filter or repar or embedded, those things, but we cannot say that only one particular method or one type of filter method will be can be used everywhere. Okay. There are some other constants, as I've already mentioned in that means presentation, that there are some other constants from the user's point of view, like on what depends what type of data you are considering, or what is the application of the data, and mm, uh, filter method. Suppose you somebody may think that filter method can be used everywhere. Yes, that is true. If somebody can say that the filter can be used as a generic. I'm not saying that only filter method will not work in any other data like image or video data. It's not like that. On any data you can use filter. But the thing is that if you want to give preference on performance, then instead of filter, you have to think maybe
Am I audible now?
Yeah. Now it's audible.
Some technical faults are going
Okay.
on. So, yeah. Apart from that, let's say we know in the deep learning scenario, they learn the features better. So, is there any way that you can actually some features selected with the features level so that the model could be more beneficial?
Can you repeat the question some words? It's not audible to me. So can you repeat?
Yeah. So what I'm saying is that in deep learning, the feature extraction happens in during the training process itself.
Yes.
In machine learning itself, the features are we do some feature engineering so that we select the best features and fit to the particular model. So the participant asking that if is there any way to so that will it be helpful or not if we give some feature engineering before like before fitting the particular model before the model learns. So in deep learning perspective, are there any techniques?
Okay. So basically, in deep learning, uh, if you use CNN, convolution neural net, then automatically it can extract some features at the time of training. Okay, and now your question is, if from deep learning perspective, can we select some features?
Yeah, can we give some before training the particular model? So the participant said that if there are any techniques that could be applied on the feature engineering deep learning or the feature engineering is more beneficial in classical machine learning itself.
Okay. So it's true. We can give, definitely we can give because say suppose I am working on network flow or a network window I am considering. Now that network window, the data of the network window, I want to analyze by some using deep learning, maybe CNN or RNN or whatever, maybe. Now the thing is that this deep that network window, some researchers they are converting that window to image. There's some technique by which we can convert that things to image. And on image, as usual, CNN can extract some features and automatically it can do the rest of the things. And instead of converting it to the image, then keeping it as a raw data, suppose I apply some filter method or extraction method, 20, 30, 40 features. We can apply some feature selection method to select optimal features. Those features you can feed into deep learning, deep neural network. No problem. That type of, that means features will be 1D, one dimensional, not 2D like image. Okay, and suppose if you want to use CNN, then your input to the CNN will be 1D CNN. In that that is feature input will be 1. In that one-dimensional feature input will be your select.
Okay, so I think that is clear. Anyone from the participant, if you have any questions, you can unmute yourself and ask it directly.
Hello.
Yeah.
Good evening, sir.
Yeah,
This is Shweta.
yeah.
Good evening, sir. May I know some source of data sets? I am working with dynamic spectrum management, and I want to access some data sets, and I am new in this research fields. So may I know
What is
where can
what is your area of research?
sir, dynamic spectrum management for 5G networks. But I want to implement some machine learning aspect in this field. So that's why. But from Kaggle, I have downloaded one, but I'm using MATLAB 2021 R2021A version. So there I cannot access the data set. I have downloaded one 5G radio data set, but somehow I cannot import that one. So may I know, sir, where from can I get some accessible data sets so that I can execute my
Machine learning resource. As is concerned, basically we are using UCI repository, Kaggle, and GitHub. Okay, so users search in both key sources and for machine learning purpose. But since your application area is something different, so more or less I'll not be able to give you the exact answer of your query because I'm working on the particular area. But you can search in Kaggle or UCI machine learning repository or maybe in GitHub.
Yes, sir.
You just try. Sure, that you will get because 5G data on your a couple of them will not be publicly available. Okay.
Sir, I know some data set name, but if that data sets are also can be downloaded, that will be okay. But that data sets are also not available anywhere.
So
That is
you do one thing. You can send a request to the publisher or the author if somebody has generated some from own laboratory. They may have generated some data. So or some people have already used the data and they have this paper. So to the author, you can send on request for accessing the corresponding data.
so. Sir, one more thing, maybe you can answer this one, sir. Sir, in every aspect, whenever I am using the machine learning codes for convolution neural network or federated learning, whatever is there, but every time it is just taking that image input or image dimension. Is it so? Okay, only machine learning works for image only?
No. Machine learning, it's, see, data may be anything. Whatever I have presented in my presentation is basically numeric data. Okay, but CNN, especially CNN, if you apply CNN, then it is basically image. Okay, so if you are using CNN, then you can apply image there.
Oh,
Yeah, especially for CNN, you can use image there because from image, extraction is performed automatically. That CNN, so many that means mathematical concepts, linear algebra use to extract some features automatically in the time of training. So in most of the times you will get CNN input is image.
means you mean to say that CNN only work with images?
Not only. It can work on non-image data also, but people prefer to use CNN when they are using image. But as I have already told, many people are using network data without as an image in CNN. They are simply considering the input as a one dimension. But it's generally image with three
Three-dimensional they are giving, na? Oh, whenever I build that CNN as a one-dimensional data, then I can use data other than image, na ma'am? No, sir?
Yeah. According to your program, it's not always mandatory that you have to use that means image. Yeah. Especially CNN, in CNN, image is used. That is true. You can use non-image data. So as I told
Sir, another question. I think you are not feeling bored, sir. Sir, is there any provision? Can I modify the error function in the softmax layer?
error function in softmax. Error function.
Softmax layer. Can I modify it? Because by default it is set that is cross entropy function, but there are some more equipped error function is also there. But cross entropy function is by default in MATLAB R2021A version. So, sir, whenever I am using the predefined learned network, not I am on creating a new network, that is the predefined network I'm using, if in that case, am I able to modify or change that error evaluation function? That every time it is.
I'll be able to answer this question. Okay. Sorry for that. Will not be able to give like modify those things on because I know that you can apply the function to analyze the loss.
Yes, sir. Every time they are using only the cross entropy function.
This may be some reason. Your question.
Yes, sir.
Okay. Thank you, Sonali, for the question. So we have another question in the chat. It was said that she want to ask how feasible it is to apply feature selection. How feasible is to apply feature selection via filtering during inference? Does it hamper the runtime performance?
Filter feature selection.
How much feasible is it to apply feature selection via filtering during inference? So you want to apply feature selection via during.
It will be much better. So performance. That means performance-wise, it may not be good, but computation. So, if you want to get better performance, then you should apply reputed or hybrid. Okay. It's better to use hybrid instead of reputed. So then you will get better performance. But if you are giving importance to your computational time, execution time, then it's better to use filter or maybe hybrid. But don't go for it.
Okay.
There are two things. Filter will give you, that means filter can be applied for high-dimensional data, but you have to compromise performance. But reputed, low-dimensional data, performance will be.
Okay. So how? Okay, I hope she get her query. See, another query is that how long does it take in general to get the reduced optimal features using wrapper technique? So in general, are there any how much?
Yeah, actually, see, good question. Actually, in wrapper, we generally perform exhaustive search. Exhaustive search means suppose you have a subset of n features. First, you take one feature. Then out of n, NC1, then NC2, NC3, combination features. First NC1, then NC2, NC3, NC4, up to NCn. So it will take a huge amount of time. All right. So that means exhaustive search, definitely you are going to find this. It is true. After this you will get machine learning. Can you repeat the question?
Yes, the question was how long does it take in general to get the reduced optimal features using wrapper?
Yeah. How long it's say? No one can say that means maximum time will be this NC1, NC2, NCA. Because you are sitting all the pieces. Possible. It depends. If you ask me how long, it depends on the size of the data. If you are taking thousands, say for gene expression data, in gene expression data, there may be 1 lakh features. So in this case, time will be significantly high. In case of network data or some other data, if you take 20 features or 50 features, definitely that time will be less. So it depends on the dimension of the data.
Okay. I hope she has got her query. Keeping, sir, this topic is quite interesting. So questions are coming down. We can take the last question. And maybe after that, if you have any doubt, then contact directly with the professor, or you can mail to us. We forward a particular query to it with you. So for the last question, the participant asking that, can I use feature selection for IoT data integrity in beyond 5G? Data integrity, you want to use for feature selection.
Data integrity.
How long can I use feature selection for IoT data integrity?
IoT data integrity. Yeah, okay. You can, yeah, basically see IoT data means you are taking some sensor device data and then the data may be in a different middleware to be used, and with the help of the middleware, you are computing some middleware format. And at the time of analyzing in the cloud, yeah, definitely you can analyze. Analysis you can use selection. No, data, yeah, definitely you can apply.
Okay. Okay, sir. Thank you. Thank you for this interesting talk. As a like, we actually plan to intend this in a physical format, but as the current scenario is quite improved, but still we thought to go for a physical one, virtual one. We hope we can do some physical interaction in due course of time, etc. But as a token of gratitude from our side, we want to present this virtual memento.
Yeah, thank you so much. Thank you so much, IEEE Computer Society, for students, all the students in the world. I'm very much happy to receive this. Thank you all. Okay, steady on. The best.
Thank you, sir. And I will request everyone to kindly switch on their camera so we can have a group photo of it, sir. Whoever wants to be a part of it, so they can kindly switch on their camera. That's it. Can take a photo for today's event. Anjali, kindly let us know when it is done.
Yeah, just give me a second.
Yeah. Sure. And everyone, please, whoever feel comfortable can kindly switch on their camera.
Yeah, it's done.
Okay. Okay. Thank you, everyone. Thank you, sir, again for giving us this wonderful talk on physical interactions with you time. Sir.
Thank you. Thank you. Can I leave now?
Yes, sir, sure. Thank you, sir. Yeah.
Okay. Okay.
आपके द्वारा डायल किया गया नंबर अभी व्यस्त है